Okay, so now the spine, head and neck are rigged, so let's turn our attention to the limbs. First, we're going to wire up the FK controls, and these are very similar to how we built the FK spine. Let's hide the leg controls for now and focus on the arms. All we need at this stage is for the FK controls to move and rotate the FK joints. As we are focusing on FK, we can hide the IK controls for now. And these pull vector controls. We will be looking at those in the next video. I'll just find the arm group in the outliner. So the root control moves the whole arm, but the FK controls don't currently follow it. So we need to make a few changes to how this works. Let's hide the IK joints first. And move the arm IK and FK joints out of the arm group. And also delete that group. I realise this will break things for now, but we need to rework the hierarchy so the FK controls work with the rig. Next, we need to clean the translations from the joints. So just as we have done many times before, move the values from here down here, or use the script provided to speed things up. That's the IK joint done. Now the FK. So you see the FK arm has rotated to here. This is because we have joint orient values down here, which are now being applied on top of the offset parent matrix values. And we've encountered this issue before. So we just need to remember when working with joints, we need to remove those too. I'll do the same on the IK joint too. We now need to repeat this for the rest of the FK joints, so we can connect the controls like we did with the spine. So copy the translate Y here, down to here. This now doubles the distance this joint is from its parent, so we just need to zero out the main attribute to move it back. And now do the same with the hand FK joint. Reset this to move it back. So now we can set this arm up in exactly the same way we did the spine, using direct connections, which is why we needed the joints translations to be zeroed out. Open the node editor and bring the FK controls in. Just reorganize these. And now bring the FK joint in too. I'll move these so they are next to the same controls. Now connect the hand controls rotate attribute to the hand FK joints rotate attribute. And also connect the translations. Repeat this for the lower arm, connecting the rotations and translations to the lower arm FK joint. We need to do something different for the upper arm. If you remember, we had to connect the spine differently too, so it would inherit any parent translations. This time, connect world matrix 0 to offset parent matrix. We can move the root now and the FK arm controls follow. If we used direct connections, it would stay in world space, and we saw this with the spine. So now we can control the arm using forward kinematics. Nice and easy, and we didn't need to use any offset groups or constraints. While we're here, we also need to check the rotate orders. You see, the joint is set to Y, X, Z, and the control is X, Y, Z. We ideally need these to match. So let's update the control. I don't know if you did, but did you notice that the arm moved slightly as I changed it? It was only a little movement, but this is why it's important to update the rotate orders, so the controls and joints are synchronized. If you do this later, once the character has been animated, the animation would change and need to be redone. Let's update the other controls. Okay, that's the arm done. Let's reset these. So now we need to add the root control back in, so the whole arm moves with it. Let's bring that into the node editor too, and connect its World Matrix 0 attribute over to the upper arm FK controls offset parent matrix attribute. Okay, good. The FK arm now moves with the root control. Let's test this with the main root control now. We have a problem. But we also had this with the spine, if you remember. The upper arm FK control now has a double transform because it's inheriting the main root's rotation as well as the arm root controls. So we need to remove this. Bring the main root control into the node editor. Press Tab and create a new Mult matrix node. With this node we can add the matrix values together from multiple nodes. Rename it to Upper Arm FK Mult. Move the connection from the arm root control, so we are connecting its World Matrix 0 attribute to the Mult matrix node's Matrix In attribute. We can now open the Matrix In attribute here. Now connect the root control's World Inverse Matrix 0 attribute, that's a mouthful, to Matrix In 1. We use the inverse matrix values because they are inverted versions of the main world matrix values, so this will essentially take them away. So the Mult matrix node is now using the arm root's world matrix values, but then taking away the main root control's values. Now connect matrix sum to the upper arm FK controls offset parent matrix attribute. Okay, so now we can manipulate the root and the arm stays where it should be. We can also oppose the arm using FK. And it stays solid no matter where we put the root. Okay, let's reset these. So now the arm moves with the root control, so let's add in the option for it to either rotate with it or stay in world space. So we are essentially adding some space swapping functionality, but don't worry, we will go over this in more depth in a future video. First, what we need to do is store the main arm's position. So press Ctrl and G to create a new empty group. Rename this to Arm Root Left World Space. Now use the Match Transformations tool to match the group to the arm root's position and orientation. So that's now in the same place. Make sure you also clean the values on the group, moving them to the Transform Offset Parent Matrix section. We need a new node now. This time create a Blend Matrix node. This will give you the option of blending between a number of other nodes. Call this Upper Arm Left FK Blend. Make some room for it over here. Connect Matrix Sum from the Mult Matrix node to Input Matrix. Just open the attribute editor now. So up here are the values we just connected, taken from the arm root control. So this is the node we want to blend. Let's click this button here to add another item to the list. And now connect the arm root world space group's World Matrix 0 attribute to the Blend Matrix node's Target Matrix attribute, which is under the Target 0 group. Now that's appeared here. What's good about this node is we can specify what attributes we want to use, so we can deselect Translate here so the arm will match just the spine's orientations. Now connect the Output Matrix attribute from the Blend Matrix node to the Upper Arm FK Controls Offset Parent Matrix attribute. Here we go. if I rotate the root control, the arm doesn't move. But if I move it, it does. This is because we are telling it to instead use the world space group's orientation. What we can do now is use the envelope attribute here to simply blend between the root control's orientations and the world space group's orientations. The next step is to add this functionality into the rig, so the animator can easily access it without having to find the blend matrix node. To do this, we can use the follow attribute we added to the upper arm FK control. Although thinking about it, it would make sense if this was a float instead of an enum, so the animator can blend between the two states rather than snapping from one to the other. Let's add a new float attribute. Call it World Orient. Set the minimum to 0 and maximum to 1, matching the limits of the envelope attribute. And add that. So we will use this instead. Now connect World Orient over to the envelope attribute on the blend matrix node. Let's also delete the follow attribute now too, as it's no longer needed. We can use this now, or should I say, the animator can use this now to make the FK arm rotate locally so it follows the root control or stays in world space and follows the group. Okay, so that's set up now. Let's reset these. The next step is to now make sure the arm follows the spine. You see, as we manipulate it, the arm just floats here and doesn't move, which isn't natural. First we need the left arm group back. So let's create it again and move it into the rig systems group and rename it. Move the IK, FK and world space group into it. Now create two new groups. We want two so we can store both the IK and FK positions of where the arm should be. Rename them so the first is shoulder left IK world space and the second is shoulder left FK world space. Now match these to the arm root control, so they are in exactly the same place. Actually, this should be left FK, so I'll change that to L. Parent the IK group to the IK shoulder control so it follows it. And the FK group to the spine 3 control. Let's also clean the attribute values too, again moving them down to the offset parent matrix section. There we go. And now back to the node editor. I'll just clear this. Bring in the new IK and FK groups. And also the left arm group. All we want is the left arm group to blend between these two shoulder groups. So as the animator blends between IK and FK, the arm will move to the correct spine. So to do this, we need another blend matrix node. Rename this to shoulder IK-FK blend. Connect world matrix 0 from the IK group to the input matrix attribute on the blend matrix node. Go to the attribute editor and add a new item to the blend matrix node. Now connect the world matrix 0 attribute from the FK group to the target 0 matrix attribute. Now connect output matrix to the arm root group's offset parent matrix attribute. Now if I rotate the FK spine, the arm follows. I'll just move this. If we switch to IK, nothing happens, but that's because we also need to tell the blend matrix node to swap to the IK group too. Add the cog control to the node editor. Let's find the IK FK switch attribute and connect that to the envelope attribute on the blend matrix node. Now the arm follows when using the IK spine. We can also blend between the two and the arm follows. Let's test the main root control again. Now things have changed. Right. So we have the double transform issue again. So all we need to do is remove the root's influence again, just like we did earlier. Let's make some room and create a new mult matrix node. Call this shoulder left IK mult. Duplicate this and update the name to FK instead of IK. And remove that one. Let's add the root control to the node editor too. Connect World Matrix 0 from the shoulder IK group to the shoulder IK mult node's matrix in attribute. Now connect the root control's world inverse matrix attribute. Remember, we use inverse because we want to take these values away. Connect this to matrix in 1. Now we repeat this for the FK side. So world matrix 0 to matrix in. And then world inverse matrix from the root control to matrix in 1. We now need to connect these to the blend matrix node. So matrix sum to input matrix. And matrix sum from the FK mult matrix node goes to target matrix, under target 0, just here. We can rotate the root now and the arm stays in position. You will also notice that the arm isn't rotating with the spine, it's just staying almost level. This is because we have its world orient attribute set to stay in world space. If I change this to 0, the arm now stays orientated with the spine. Okay, so we have the FK arm set up, and the arm also follows the spine. So that's a lot to take in, so I hope you were able to follow along. With the right arm, you just follow exactly the same steps, so I won't go over it again. If you're unsure, just re-watch the video, but apply it to the right arm instead. You can also apply the same process to the legs too. What I would recommend is using the hip control as the main control when blending the legs between the IK and FK spines, rather than using the cog. This will just give you more flexibility when animating the hips. Okay, so what I'm going to do is I'm going to quickly whip through and update the other limbs now, so I'll be back in a sec to show you what they look like. Okay, so here we have all the FK limbs rigged. We can move the cog control and they all follow. Just as I mentioned before, you can use the hip control on the IK spine to control the legs. And the limbs follow when the spine blends between IK and FK. Okay, so that's the FK limbs set up. Just to further illustrate the world orient attributes we added, if I rotate the character now, the arms and legs rotate with him. If I select the FK controls and set world orient to 1, You see the difference? The limbs move with the torso, but don't rotate with it, so they remain level. This is a nice option for the animator, so the limbs can be more independent. Okay, so that's FK limbs covered for now. So let's move on and look at setting up the IK limbs in the next video.